Welcome back everyone. This is the third lecture of the MATLAB course. In this lecture, we are going to learn about vectors and matrices and some very basic commands related to them. Recall from the very first lecture, I had said that MATLAB treats everything as matrices. So a scalar is basically a 1 cross 1 matrix. A vector is a 1 cross n or a n cross 1 matrix. So we will basically be learning about matrices in this lecture. So let's get started with today's lecture. To define a matrix, its elements are enclosed in a pair of square brackets. Recall from the very first lecture, I had written something like A equals 6. We can also write it as A equals 6 within a pair of square brackets. So what this means basically is that A is a square matrix whose size is 1 cross 1 and it is having only one element, and that is 6. So A is nothing but a 1 cross 1 matrix or a scalar. So both of these commands will mean the same, that is A equals 6 or A equals 6 within square brackets. So this is how you create scalars. Now say if you want to create vectors, so you can write something like A equals within square brackets 1 comma 2 comma 3. So this is creating a 1 cross 3 row vector. So what this means is there are 3 columns and 1 row. You can also create row vectors by using space instead of the comma. So you can write something like A equals 1 space 2 space 3 within square brackets. And this is also creating a row vector. So if you want to create row vectors, you can write the elements in a pair of square brackets and separate the elements by using a comma or a space. Now say if you want to write column vectors, so you can write them in this way. So you can write A equals within square brackets 1 semicolon 2 semicolon 3, and this is creating a column vector. So to create row vectors, use a comma or a space, and to create column vectors you can use semicolon. Recall from the last lecture I had said that semicolon is used to denote the end of a line. So in this vector definition, the semicolon is used to denote the end of a row. So in this case, there are 3 rows. So the semicolon is actually denoting the end of the first row, the end of the second row. For the third row, you don't need to use a semicolon over here. If you want to create a matrix with more than 1 rows and columns, you can write something like this. A equals 1, comma 2, comma 3, semicolon 4, comma 5, comma 6, semicolon 7, comma 8, comma 9, square brackets. So recall what I said, that comma is used for row vectors and semicolon is used for column vectors. So here you can see both comma and semicolon. So what this will do is it will create a matrix whose first row will contain 1, 2, 3. Then there is a semicolon. So it will go to the next row and it will create another row with the elements 4, 5, 6. Once again, there is a semicolon over here. So it will create a new row and then it will insert the element 7, 8, 9. So in this case, we should get a 3 cross 3 matrix. So you see, we have got a 3 cross 3 matrix like this, the elements that we have defined over here. Now, whenever you create a matrix, MATLAB assigns certain indices to each of the elements to identify them. These indices are nothing but the row and the column number of the element. For example, in this matrix, the row number of this element is 1 and the column number is 2. So MATLAB will assign an index 1, 2 to this element. Similarly, the row number of this element is 3 and the column number is 3. So MATLAB will assign an index of 3, 3. You must remember that in MATLAB, the indices are numbered starting from 1. In some other languages, you may find indices that are starting from 0. So note the difference between the two, otherwise you will get some error while accessing the elements. Now say you want to access the elements of these vectors and matrices. What you have to do is write the name of the vectors or matrices, and then you can write the index of the element that you want to access within a pair of parentheses. So for example, if I want to access this element, I will write something like A within pair of parentheses 1, comma 2. So this means I am accessing the element which is in the first row and the second column. So the first element over here is denoting the row number, and the second element over here is denoting the column number of the element. So if I press enter, you see that this element has been returned. If I want to access this element, I will write something like A3, comma 2. So this will return the element that is in the third row and the second column. So you see MATLAB is returning the value of 8. Now remember what I said just now, the indices in MATLAB start from 1. So in this case, if you want to extract an element whose index number is given by say A0, 2, MATLAB will return an error saying that array index must be a positive integer or logical value. If you want to extract an element of this matrix whose index is given by say 1, 4. So notice that the size of this matrix is 3 cross 3, but you are trying to extract an element whose column number is 4. So MATLAB will return an error saying that array index is out of bounds. So while accessing the elements of the matrix, be sure of the size of the matrix and the index that you use. So this is how you can extract individual elements from a matrix. Now say if you want to extract a single row or a single column. So we have this matrix. Say I want to extract the first row. So what I will write is A1, colon. So the colon symbol here means extract all elements. So what this command will tell MATLAB to do is go to the first row, and from that row extract all the columns. So if I press enter, MATLAB will return me all the columns from the first row, that is 1, 2 and 3. Now say if I want to extract the second column, what I will write is A colon, 2. So what this command is telling MATLAB to do is go to the second column, and from that second column extract all the rows. So MATLAB is going to the second column and extracting all the rows, that is 2, 5, 8. So this is how you can extract individual columns and rows. You can also extract multiple rows and columns at once. But before showing how to do that, I will just create a larger matrix so that it is easier to understand. So I will write a rand 6. So what rand means I will explain in a bit, but for now focus on the fact that we have a 6 cross 6 matrix. Now say I want to extract the second and the third row. So what I will write is A 2 colon 3 comma colon. So what this command is telling MATLAB to do is go to the second row and extract all the elements from that row. Keep on increasing the row number until you reach the third row and extract all the elements from those rows. So if I press enter, MATLAB is extracting the second and the third rows. So I will just explain once more what this command is doing. So this command is telling MATLAB to go to the second row and keep on increasing the row number by 1 until it reaches the third row, and from all those rows extract all the elements. You can also extract multiple columns in a similar manner. So you can write something like A colon 4 colon 6. So what this command is telling MATLAB to do is go to the fourth column, keep on increasing the column number by 1 till you reach the sixth column, and from all these columns extract all the rows. So you can see these last 3 columns have been extracted by using this command. So this is how you can extract multiple rows and columns. However, you can see that by using this syntax, only consecutive rows or consecutive columns can be extracted. If you want to extract non-consecutive rows, say if you want to extract the first row, the third row, and the fifth row, you can do so by creating another vector whose elements will be the rows or columns that you want to extract. So I will create a vector, say B, and I will store the row numbers that I want to extract. So I will write B equals 1, 3, 5. So these are the row numbers that I want to extract. And now I will write A, B, colon. So what this is doing is it is extracting the first row, the third row, and the fifth row from A. So I hope that clears up how to extract rows and columns from matrices. Now that we have learned to create matrices, we will learn some mathematical operations related to them. So I will just clear my screen. So I will create two random matrices over here. So I will write A equals rand 3, B equals rand 3. So what rand stands for is random number generator. It can generate random scalars, vectors, and matrices. So if you want to create a random number, say you can write rand 1, 1. So this is creating a random matrix or random scalar whose size is 1 cross 1. You can create random vectors by using a similar command, say rand 1, 5. And this is creating a row vector. You can create column vectors in a similar manner. You can write rand 6, 1. And it is creating a random column vector. You can create random matrices by using rand 3, 4, for example. And this is creating a 3 cross 4 random matrix. Now, if your matrix is square, you can just write a single number instead of both the number of rows and number of columns. So you can just write rand 4, and this will create a 4 cross 4 square matrix. But if your matrix is non-square, you have to write both the row number and the column number. So here we have two random matrices A and B, and I will now show you some very basic mathematical operations. So if you want to add these two matrices, you just have to write A plus B, and this will add the two matrices. If you want to subtract the two matrices, you can write A minus B, and this will subtract the elements of the two matrices. If you want to perform multiplication on these two matrices, you can write A star B. And what A star B is doing is it is actually performing a matrix multiplication on these two matrices. So recall that matrix multiplication means you will take the elements of this row and the elements of this column, and you will multiply these individual elements and you will add those results to get this first element. Similarly, you will take the elements of this row and you will take the elements of this column and you will add those elements after multiplying them to get this element. So this is actually matrix multiplication, and you can do it by simply writing A star B. If you want to do element wise multiplication, that is, you take this element and you take this element and you multiply them together to get the result. So that is called element wise multiplication. So you have A, B, and now if I write A dot star B, so what this is doing, it is taking this element, it is taking this element, multiplying them together, and the result is this element. Similarly, it is taking this element and the corresponding element in this matrix, that is this element, and it is giving the result over here. So dot over here signifies element wise multiplication. If you don't use dot, it is simply matrix multiplication. You can also do matrix division as well. So you must remember that you can't divide by matrix. So matrix division means something else over here. So for matrix division, you can just write A by B. So what this division sign actually means is MATLAB is actually performing the operation A multiplied by inverse of B. So INV is actually the command to find the inverse of a matrix. So A by B is actually finding the value of A multiplied by inverse of B. And you can see that the two results are actually the same. You can also write A backslash B. So what this is doing is it is performing the operation inverse of A times B. So you can see that the two results are same. Now say if you want to find the size of a matrix, say you have the matrix A, or let me just create another matrix A rand 4, 5. So this is a 4, 5 matrix. Now say you want to find the matrix size. So for that, there is a command called size of A. And this is going to return the number of rows and the number of columns in the matrix. There is also a command called length of A, and this is going to return the maximum of the number of rows or the number of columns. So in this case, the maximum is 5. So length of A is returning 5. So size of A will return a vector, length of A will return a scalar. Now say you want to delete particular rows or columns of a matrix. So in this case, say I want to delete the first row of this matrix. So I will write something like A 1 comma colon equals an empty pair of square brackets. So you can see that the first row has been deleted from this matrix. You can also delete particular columns of a matrix. So if I want to delete the third column, so I will write A colon comma 3 equals an empty pair of square brackets. So this has deleted the third column. So this is how you can delete rows and columns. These are all the commands that you will be needing on a day-to-day basis while writing your programs. Till now, we have learned two basic commands, rand and inv. Rand is used for creating random matrices. Inv is used for finding the inverse of a matrix. Now we will learn some more commands that you will need frequently. So the first command is I. So I is used for creating matrices with 1 in the diagonal entries. So if I write I 3, 4, you can see that a 3 cross 4 matrix has been created whose diagonal elements are 1. If you just write I3, it will create a square matrix of size 3 cross 3 whose diagonal elements are 1. Basically, it will create an identity matrix. If you want to create a matrix whose all elements are 1, you can write something like 1s 3, 4. And this will create a 3 cross 4 matrix whose all elements are 1. If you want to create a matrix whose all elements are zeros, you can write something like zeros 4, 5. And this is creating a 4 cross 5 matrix with all the elements as zeros. So previously we learned about rand. It creates random matrices. However, you can see that all these elements are fractional numbers. Now, if you want to create random matrices with integers as the elements, then there is a separate command for that, that is rand I. And the syntax is rand I, and within a pair of parentheses, you will write 3 numbers. So the first number will denote the range up to which you want the integers. So say for example, here I write 10, and the next two numbers will denote the size of the matrix that you want to create. So for example, here I write 3, 4. So this will create a 3 cross 4 matrix like this, where all the elements are integers and the elements are in the range of 1 to 10. So this is how you can create random integer matrices. There is a command called linspace which allows you to create 100 uniformly spaced points between two numbers. For example, here I will write linspace 1, 5, and this will create 100 points that are uniformly distributed from 1 to 5. If you don't want 100 points, you just want 20 points. You can write something like linspace 1, 5, 20. And this will create 20 points between 1 and 5 that are uniformly distributed. There is a similar command called log space, and this will create 50 logarithmically spaced points between 10 to the power a and 10 to the power b. So for example, here I write 10 log space 1, 4. So this will create 50 points between 10 to the power 1 and 10 to the power 4. So you can see that the first number is 10 and the last number is 10 to the power 4. So don't confuse this number as 0.001. There is a 10 to the power 4 multiplied at the beginning of this array. Now, if you want 20 points instead of 50 points, you can follow a similar syntax like this in the case of, as in the case of linspace. Now, say you want to create an array of numbers from 1 to 10 with a spacing of 1. So there is a simple command for that. You can write 1 colon 10. So this has created an array from 1 to 10 with a spacing of 1. You can write say -4 to 6, and this has created an array from -4 to 6 with the spacing of 1. If you want to create an array with your own spacing, you can write something like -3, 0.5, which is your spacing, 7. And this will create an array from -3 to 7 with the spacing of 0.5. So the syntax is basically the beginning of the range followed by the spacing that you want, followed by the end of the range. And all of this will be separated by a colon. So the colon is basically used to signify range. Recall that when we were trying to extract rows and columns from matrices, we used the colon symbol to specify range of rows and columns. You can create magic squares like this. So this is the command for creating a magic square. Magic square is one where the sum of every row and every column is the same. So you can see that the sum of this row is 34 and the sum of this column is also 34. You can verify the sum of all other rows and columns and that they will turn out to be 34 as well. So this is how you can create magic squares. If you have a matrix like this, you can find its determinant by writing det A, and this will calculate the determinant of a matrix. If you want to find the transpose of a matrix, you can write A transpose or A apostrophe, and this will calculate the transpose of the matrix. If you want to find the norm of a matrix, you can write norm of A, and this will find the L2 norm of a matrix. If you want to find the L1 norm, for example, you can write norm A, 1, and this is the L1 norm. If you want to find the L infinity norm, you can write something like norm A, INF, and this will calculate the L infinity norm. So the default norm is actually the L2 norm. You can see that this result and this result is actually the same. If you don't know what determinants or norms or transpose of a matrix are, you can read any book on matrix algebra. These are the most of the commands that you need to know while working with vectors and matrices. I may have missed a few commands, but I will cover them in later lectures as and when they pop up in our program. So let's keep this lecture till here only. We have learned a lot of commands in this lecture. If possible, try to experiment with those commands to become habituated with them. In the next lecture, we'll learn about if-else statements. So if you liked this video, hit the like button and subscribe to my channel. See you in the next lecture.